Today, we're going to pull back the curtain on the AI magic that's behind, well, pretty much everything these days. From chatbots to AI writers, we're breaking down how large language models, or LLMs, actually work. Let's dive right in. You've probably done this, right? You ask an AI a question, and this perfectly crafted answer comes back in seconds. And you just have to sit there and think, how? How on earth does a machine get what I'm asking and write like a person? Well, that's exactly what we're going to figure out. So, let's get into our first section. It all kicks off with an idea that is, believe it or not, super simple. At its very heart, an LLM is just playing a really advanced prediction game. No, seriously, that's it. This whole incredibly complex system is built on one core job. Look at a sentence and guess what word is most likely to come next. Think of it like a next word guesser on an unbelievable scale. Okay, let's make this super simple. If an AI sees the phrase, "the cat is on the," what would it guess? Your brain does this automatically, right? You're already thinking of a few words, and the AI does the exact same thing.
So, how does it choose? Well, it doesn't just pick one, it looks at the context and gives a probability score to thousands of options. In our sentence, Matt has a really high probability. Rug's a pretty good bet too. But a word like moon, the probability is practically zero. Why? Because in all the books and websites it's read, cats just don't hang out on the moon. The key thing here is that it's not thinking. It's all just math and statistics.
All right, so we get it. It's a prediction game. But what's the engine making it all happen? To see how it calculates all those probabilities, we need to peek inside the AI's brain. The tech that powers all of this is called deep learning. It uses these things called artificial neural networks, which are complex systems kind of modeled after the connections in our own brains. And these networks are designed to do one thing incredibly well: find patterns in just massive amounts of data. Modern LLMs use a special kind of network called a transformer. On the surface, it seems simple. Your text goes in and an answer comes out. But the real magic, the absolute game changer, happens right in the middle with something called the attention mechanism. This is the secret sauce. It lets the model figure out which words in the sentence are the most important for understanding the context. It's like the AI has a highlighter and it's marking the key words it needs to focus on. So for "the cat is on the mat," the attention mechanism knows that cat is the crucial piece of info for making a good prediction. Okay, so the AI has this powerful brain. But a brain's not much use without knowledge, right? So where does an LLM learn about things like cats and mats and grammar in the first place? It learns from what's basically a library of everything. It learns from an amount of text that is just hard to even wrap your head around. We measure it in something called tokens. A token is basically a word or a piece of a word, and we are talking billions, sometimes trillions of them. That enormous scale is what lets it pick up on all the tiny, subtle patterns in how we humans talk and write. And where does it get all this data? Well, think about a huge chunk of the internet. It's trained on millions of digital books, massive websites like Wikipedia, countless news articles, scientific papers, you name it. By churning through all of this stuff, it's not just learning words, it's learning grammar, context, and the zillions of ways ideas connect to each other. But here's where it gets even cooler. Just predicting the next word in a line isn't quite enough. To be really smart, the AI needs to understand the meaning behind the words and the relationships between them. This is where we get into this wild concept called embeddings. You see, the AI doesn't see a word like cat the way you and I do. It turns that word into a long list of numbers, a vector. Now here's the aha moment. Think of those numbers as a set of coordinates, like GPS for a word on a giant complex map of meaning. This process puts every single word in a specific spot in this huge space. And on this giant map, the locations aren't random at all. Words with similar meanings get placed close together, like houses in the same neighborhood. So king and queen, they're going to be close neighbors on the map. Cat and dog, they're in a totally different part of town, far away. This is how the AI starts to understand that the idea of royalty is very different from the idea of pets. It's what allows it to generate text that actually makes sense. Okay, so let's recap. We've got all our pieces: the prediction game, the transformer brain, that massive library of data, and the crazy map of meaning. Now, let's see how it all clicks together when you actually type in a prompt. So it all starts the second you hit enter. First, the model instantly turns your words into those number coordinates, the embeddings. Then, the transformer network looks at those numbers and predicts the single most likely next word. It spits that word out, adds it to the sequence, and then does the whole process over again.
and again, word by word, until it decides the thought is complete.
And the final result is this perfectly smooth, coherent sentence that looks like a person wrote it. But now you know the secret, right? It was actually built through a lightning-fast chain of predictions, assembled one single word at a time, all based on statistics.
And that brings us to a really fascinating, kind of mind-bending final thought. If everything an LLM does is just based on spotting mathematical patterns and predicting the next most likely word, is it actually thinking? Or is it just the most incredible pattern matcher we've ever built? What does it really mean to understand something? That's definitely something to chew on.